Thank you all for a wonderful event and all the sponsors, CUNY, Clay, Frame, the Finnish Heritage Federation, and everyone else. I think it's really quite a nice event, and I'm honored to take part of it. I'll just begin with Wittgenstein, a famous passage from the Philosophical Investigations. He's been speaking about a doctrine of logical atomism found in Plato, and in a characteristic move that Wittgenstein makes, he says, let's think of what it would be like for this doctrine that he has certain misgivings about to actually be true. Let's concoct such a scenario. Think of a language game, term of the art for Wittgenstein, for which this account from the Theaetetus is really valid. The language serves to describe combinations of colored squares on a surface. The squares form a complex like a chessboard. There are red, green, white, and black squares. The words of the language are correspondingly these letters. And a sentence is a series of these words. They describe an arrangement of squares in the order, and he displays this board. And so, for instance, if I utter RRBGGG, that sentence describes the following arrangement. Some editions have the squares actually colored in. Okay. And he says here the sentence is a complex of names to which corresponds a complex of elements. The primary elements are the colored squares. So the doctrine with which Wittgenstein has misgivings is a doctrine about there being absolute, simple, atomic elemental propositions or facts or building blocks of reality or of thought. So Wittgenstein says, I can imagine this notion of absolute simplicity as given by a conventional game that we play. So I'll describe such a game, and in the description of the game, there will materialize before our discussion, in the course of that description, some notion of atomism, some notion of simplicity there in the description. So is that what Plato was on about? So Wittgenstein engages in dialectic, and he has an interlocutionary voice responding, but are these simple? I mean, you described a game. It has its elementary parts as given by your description, but I'm interested in the real simple things, not what happens to be simple in your game. And Wittgenstein replies to himself, I don't know what else you'd have me call the simples. What would be more natural in this language game? But under other circumstances, I could call the monochrome square composite, rather than say the colors themselves and the locations themselves as two different sorts of simple, or I'll call those squares themselves composite, made out of the color themselves and the locations themselves, and those things be simple. But the concept of complexity might also be extended so that a smaller area was said to be composed of a greater area and another one subtracted to it, sort of a monstrous notion of simplicity. Let's imagine every two rectangles being a simple, and then to get any particular square, you have to do a combination of subtraction in order to get to it. I could imagine such a thing, says Wittgenstein. But that would be in a different game. That would be in other circumstances, not the situation that I described. So a lot of interpretation about such Wittgensteinian passages. It's connected to issues of rule following and issues of ostensive definition, and I don't want to rehearse all of that Wittgensteinian scholarship, but I'll just mention that there was a reading of this insight of Wittgenstein's that had some currency for a long time, that Wittgenstein was putting forth some notion of conventionality, that there's no such thing as how one ought to proceed in obeying a command or carrying out a rule, other than whatever people just conventionally decide upon by fiat. There's no such thing as simple. Simple is given by our decisions to treat certain things as simple, and there's no fact of the matter beyond those decisions. That reading of Wittgenstein has been much discredited. And what I want to suggest here, and I think it's pretty evident if you think about it, in Wittgenstein's own description of this, when he begins describing the language game, he himself, in the very description, before he's within the game, describes things as he has a starting point, the colored squares on the surface, the words RGWB, etc., giving rise to this notion of maybe a contingency of necessity. It's not up to us to, in fact, treat these alternative notions of simplicity, where a rectangle we will treat as simple, and we'll think of the subtracted part of it as somehow composite. In other circumstances, perhaps that could be the case, but that's not a convention that is actually available for us. So on the one hand, Wittgenstein is trying to discredit a notion of absolute essential simplicity, and simultaneously trying to awaken us to the fact that although maybe the conventions that we inhabit give rise to notions of simplicity for us, those aren't conventions about which we really have any options. They're things that are deeply embedded in the way that we live our lives. They are things with a long genetic history. Our thinking occurs within those conventions, and so there really is no way out of them, but maybe they do change over time. This is the view that I want to put forward. What is Wittgenstein unhappy about? The Dietatis, some ancient doctrine of logical atomism? I think that Wittgenstein was unhappy about something that still has a lot of forceful attention today, and I'm going to illustrate it with one thinker from the 19th century who was perhaps a proponent of a highly caffeinated version of this doctrine, but one that I think you will find some similarities with in other thinkers, foundationalist philosophers of mathematics and logic, Frege, others, and even contemporary research. Bolzano drew a distinction between what he called proofs that merely allow us to conclude that a proposition is true, as opposed to proofs that display what he called genuine consequence relationships. They somehow unearth the grounds or the reasons why a proposition is true. Here's Bolzano. In the realm of truth, that is, in the sum total of all true judgments, a certain objective connection prevails, which is independent of our actual or subjective recognition of it. As a consequence of this, some of these judgments are the grounds of others, and the latter are consequences of the former. To represent this objective connection of judgments, that is, to choose a set of judgments and arrange them one after another, seems to me to be the proper purpose to pursue in scientific exposition. Now, instead of this, people often think that what we really are after is certainty or strength of conviction, just understanding, building up a registry of true facts. I think what science should really be doing is more disclosing the objective grounds for those facts, explain the truths that we discover in the course of doing science. Why? Why do this? Bolzano gives 4 reasons. First, as I just said, the purpose of science should be not merely to record, but also to explain facts. Also, there's an aesthetic value that Bolzano emphasizes a lot, that Rosalie was just speaking about. Through Bolzano's special types of proofs, one is able to see one's way to a mathematical truth without recourse to ideas or terms that are off topic, what he calls atrocious detours, a phrase that's echoed by Ginson, who took up some of Bolzano's work in the 20th century. He says, if there appear in a proof intermediate concepts which are narrower than the subject, then the proof is obviously defective. It's what's usually called, he uses a Greek phrase, passing over to another genus or another kind. This is taboo. I use the Greek for reasons that will emerge. A third advantage of Bolzano's notion of proof, tracing a truth back to the absolute simple constitutive parts, is that it will afford a kind of conceptual purity, and that will have a scientific advantage because it will facilitate the discovery of new truths. He says this, for example, one must regard the endeavor of unfolding all truths of math down to their ultimate grounds as an endeavor which will not only promote the thoroughness of education, but also make it easier. And he continues, furthermore, if it's true that if the first ideas are clearly and correctly grasped, then much more can be deduced from them than if they remain confused. Then this endeavor can be credited with a third possible use, the extending of the science. We'll somehow or another, if we give up on merely trying to learn new facts, and we instead are interested in understanding the ontological hierarchy of the grounding relationships among facts as they're traced down to simple elements, then ironically enough, this will enable us to discover more new facts than we otherwise would have because the structure of the hierarchy of truths will begin to materialize before our eyes. All of these notions are a little bit suspicious today. I'm going to want to cast some suspicion on them, but you can all do that on your own. There is one interesting fourth advantage that Bolzano speaks about that maybe has slightly more going for it. He says, listen, if we're not careful in our mathematical reasoning to keep track of which things are the grounds of which other things, and we just try to accumulate truths, we could have some circularity in our proofs that is somehow hidden away in the intricate annals of mathematics, because I proved A using B and C one time, and now I'm trying to prove B, and somehow another A gets sneaking in under the rug, and I haven't really proved anything. So that's a concern that Bolzano thought he would overcome by pressing this notion of absolute simplicity. So the notion comes from Aristotle originally. I'll just point you to the bold script. To have reasoned knowledge of a conclusion is to know it through its cause, not merely to have convinced yourself that it's true. It follows that we cannot, in demonstrating, pass from one genus to another. This is the phrase that Bolzano quotes. We can't, for instance, prove geometrical truths by arithmetic. So what am I not saying? I'm not saying that there's no advantage to pursuing the topical purity project of trying to take complicated proofs like that of Fermat's last theorem and do some sort of proof mining like what Colin McClarty is doing that will eventually allow us to see in purely arithmetical terms how this theorem can be seen to be true. There's great scientific value that emerges from those projects piecemeal. Similarly, I'm not saying there's no value in normalizing proofs that occur in actual mathematics, because by doing so, we are able to perform ordinal analyses and such things that give us new scientific insight. What I am saying is that these great advantages of thinking about how you're proving things and focusing on simplicity should not be straddled with this ontological burden of being the only true notion of proof because of a sort of fetish of absolute simplicity, because I just think that is too much of a burden for these techniques to bear, and this is Wittgenstein's point. It blinds us to the role that simplicity actually plays. So some social theorists have said some things similar to what I'm wanting to say today in mathematics about the ordinary, the simple. What's ordinary and simple for us isn't something that's given a priori, but something that we can discover through a type of self-analysis. Ruth Benedict speaking about culture, other social theorists like Sachs and Shegloff, in, I think, famous publications of theirs. But since we're speaking here about aesthetics, not social science, I will speak, my analogy will be drawn from art critics. So Arthur Danto is speaking about some trends in modern art, appropriated art, found art objects. What prevents Oldenburg's creation from being a misshapen bed? He actually builds a functional bed and displays it in a gallery. He says this is equivalent to asking what makes it art. And with this query, we enter a domain of conceptual inquiry where native speakers are poor guides. They are lost themselves. I think it's a very telling remark. If you want to know what makes something art, Danto is saying, don't ask the artist. Somehow, the people who are experiencing it as art effortlessly are standing in a place that they are, their terms, their distinctions between the art and the non-art are really unknown to themselves in a way that would be hard to convey to an outsider. We'll say more about this later. It will come up again in an interesting way in mathematics. Similarly, what in the end makes the difference between a Brillo box, he's speaking about a Warhol installation, and a work of art consisting of a Brillo box, is a certain theory of art. It's the theory that takes it up into the world of art and keeps it from collapsing to the real object, which it is. Of course, without the theory, one's unlikely to see it as art, and in order to see it as part of the art world, one must have mastered a good deal of theory, as well as a considerable amount of the history of recent New York painting. It could not have been art 50 years ago. The world has to be ready for certain things, the art world no less than the real one. Danto describes, he uses a certain theoretical framework to describe how as new types of artistic expression are produced, the entire prehistory of art and all the artworks that predated that new type of expression takes on a new meaning that then the modernist is able to read back into that. So he says, think about if you classify artwork as representational or expressionist. So you could have representational expressionist art, representational non-expressionist art, its dual art, which is neither representational nor expressionist. The rows in such a column are going to correspond with Fauvism all the way up to hard edge abstraction. Plainly, as we add art-relevant predicates, we increase the number of available styles at this exponential rate. It is, of course, not easy to see in advance which predicates are going to be added or replaced by their opposites. That's creative artistic innovation. But suppose that an artist determines that H, some predicate, shall henceforth be artistically relevant for his paintings. Then, in fact, both H and non-H become artistically relevant for all painting. And if his is the first and only painting that has H, every other painting in existence at that time becomes non-H. And the entire community of paintings is enriched together with a doubling of the available style opportunities. It's this retroactive enrichment of the entities of the art world, of its own past, that makes it possible to discuss Raphael and de Kooning together, or Lichtenstein and Michelangelo together. The greater the variety of artistically relevant predicates, the more complex the individual members of the art world become, the more one knows of the entire population of the artwork, the richer one's experience with any one of its members. Pierre Bourdieu is actually here speaking about Danto, but continuing the thought and trying to broaden it. He says this: what's forgotten in the self-reflective analysis, if you try to sit back and think, gee, what makes something art? What are the criteria of beauty, of simplicity? We try to do some phenomenology or pronounce upon an ontological distinction that underwrites those distinctions. What's forgotten is the fact that although appearing to be a gift from nature, the eye of the 20th century art lover is really the product of history. I mean, along the way, people introduced new art-relative predicates, G, F, H, etc. And then when you began to learn about art and to experience art, you experienced art in the same works of art in a very different way from your forebears, because now you were able to call them non-H, whereas the whole concept of categorizing in terms of H and non-H may have not existed for your ancestors. There's a historical constructedness of our aesthetic eye. What the ahistorical analysis of the work of art and of aesthetic experience captures in reality is an institution, which as such enjoys a kind of twofold existence in things and in minds. And Bourdieu's point is that this is what Danto showed, and art critics are now open to this in a certain way, but outside of art, the primacy of the institution that underwrites our distinctions between simple and complex, between grounds and consequences, etc., is often ignored. In philosophy in particular, he says that realization has not been well made, although in social science and aesthetics perhaps it has. Certain notions which have become as banal and as obvious as the notion of artist or creator are the product of a slow and long historical process. Thus, as the field is constituted as such, it becomes clear that the subject of the production of art is not the producer who actually creates the object in its materiality, but rather the entire set of agents engaged in the field. Among these are the producers of works classified as artistic, critics, collectors, middlemen, curators, etc. Many people are involved in producing and sustaining the artistic eye, not just the creative genius of a work of art, but the elementary school pedagogues who then are able to get us to experience art at a very early stage in a way that's open to all the art-relevant predicates that allow us to classify things, that shapes the way that we think. Everyone is responsible for sustaining that evolutionary process. And the critical remarks, essentialist thought, like that of logical atomists or others, is at work in every social universe, and especially in the field of cultural production, the fields of cultural production where games in which the universals at stake are being played out, religious, scientific. We want to know the absolute truth. Therefore, we want to know the true simples, the true grounds, etc. But in that case, it's quite evident that essences are norms, and I think this is just Wittgenstein's point. Yes, we have no aesthetic eye that we can use other than the one that we have, but that doesn't mean that the essence that we pick out as this is art and this is not art, and we can maybe do this reflexively without introspection, it doesn't mean that it's the only option. It does mean it's the only option for us now. The a priori is history, he says. In order to awaken today's aesthete, so here he talks about the value of certain modernist trends, one must apply a shock treatment to him, a la Duchamp or Warhol, by exhibiting an ordinary object as it is, manage to prod in him some way, the creative, right? We, again, as Danto said, the artist maybe is a poor guide around the realm of the artistic and the distinctions between complex and simplicity because of how embedded he is in the practice. But what we can do is use certain techniques of artistic production to awaken ourselves to the primitive terms that are actually in place for us, things that are very hard for us to see because they're so close to our eyes. So, the analogy in mathematics, Poincaré makes this remark. Poincaré's anti-logicism is well known, especially as explained by Goldfarb and others. He makes in one of his famous essays sort of a throwaway remark. He himself throws it away. Immediately after uttering these words, he says, but I'm not going to let that question detain me. Well, I am. I want to pick up on this line of thought. Why is so long a preparation necessary to become habituated to this perfect rigor, the rigor of formal axiomatization in mathematics in the late 19th century? It would seem that it should naturally impress itself upon all good minds. It's supposed to have that axiomatic role, right? Primitive truths, absolute simplicity, the base structure of all complicated mathematical research. Well, this is a logical and psychological problem well worthy of study. Why does it take so long to learn what is put forth as foundations of mathematics? Easier just to do ordinary mathematics itself for many a student. Remember Danto, native speakers are not good guides, they're lost themselves, right? For someone who has already mastered modern logical foundations, these axioms are quite self-evident, and it's very hard to appreciate the difficulty in getting them under your skin for the first time. Gauss wrote a paper in 1831, which is very famous for awakening the world to the respectability of imaginary numbers. Most of the fame of the paper derives from the concluding sections where he gives a geometrical representation of imaginary numbers, similar to what had already been done by Wallace and by Agrand and other people. But I think what's truly important about this paper in Gauss is a prior argument he gives for the respectability of imaginary numbers. And this is an exercise that I want to look at that will help us begin to see how impurity and a shifting of what we will be able to experience as simple plays an important role in mathematical discovery and the evolution of mathematical thought. So, it's the theory of biquadratic residues. We have to understand what that means. A quadratic residue is a number with respect to a modulus p if there are numbers of the form x squared minus k that are divisible by p, in which case k will be the quadratic residue. Otherwise, k is a non-residue. So a biquadratic residue is the same thing. We want to find numbers k such that there's an x, such that x to the fourth is congruent to k mod p. Otherwise, it will be a biquadratic non-residue. Quadratic residues, it's that there are numbers whose square are congruent to k, and biquadratic residues are numbers whose fourth powers, there being numbers whose fourth powers are congruent to k. So this is just my own words. In studying biquadratic residues, for certain technical reasons, you only need to consider the case where p is prime and of the form 4n plus 1 that does not divide k. For such p, one seeks a scheme to classify integers k. This is at least what Gauss was interested in, a classification. I want to know, given a modulus, what are its biquadratic residues, and among its biquadratic non-residues, which ones are nevertheless quadratic residues and which are neither. That third category actually bifurcates in a way that's very technical to explain. So Gauss mentions that the theory of this classification is completely worked out for the cases k equals -1, k equals 2, k equals -2, only those three cases in previous work. That is to say, it's decidable to which class such integers belong with respect to a given modulus. He then indicates how to extend these decision procedures to larger values of k. It's quite complicated stuff, these decision procedures, but for some very small numbers and some others that he indicates in the work, he says, look, I'm able to piecemeal tell you the number k equals 3 or something like that, to tell you for a given modulus whether it's a biquadratic residue or not, or maybe it's in class 2 or maybe class 3, and here's how you go about doing that. It's a little bit different for each number, hard work. For us, I guess for Gauss, it's easy. Easy though it is to discover such special theorems by induction, it's extremely difficult to discover that, in a way, a general law for these forms, even though many similarities leap to the eye. In other words, it's as if for each k you consider you need a new idea or something like that, a new inductive proof each time. It's even harder to find proofs of these theorems. The methods used in the first treatise for the numbers +2 and -2 cannot be applied here, and although other methods might serve to settle the question about the first and third classes, these methods do not suffice for complete proofs. So Gauss is here calling for a single method to cover all cases. What will make the proof complete is the unification it brings about. Gauss again. Accordingly, one quickly sees that one can make progress in this rich domain of higher arithmetic only by employing methods that are entirely new, and this new set of methods is going to be the use of imaginary numbers. We'll see that by using them, we will have much simpler results. It's in a way an extending of the elementary. I'm asking questions about integers. I'm going to be using the complex in order to answer them. But by doing so, the whole theory will be much simpler and less piecemeal. Simpler. I see that I'm running out of time. Simple. Again, he shows that once you have a notion of classifying real integers in terms of primality of a complex sort, you're able to make the classification very easily. So for example, the number 3 is a prime number. It's also, from the composite point of view, a prime number. The number 5 is prime, but from the composite point of view, 2 plus I times 2 minus I is 5, and so it's not a complex prime. I skip much, whole section on Thurston. Let me just say this. Hilbert himself, whose utterance becomes the slogan for our conference, find a criterion for simplicity, announced in his Grundlagen a certain fundamental principle. He says, to make the discussion of each question of such a character as to examine at the same time whether or not it's possible to answer this question by following out a previously determined method and by employing certain limited means. The context of this principle are certain impossibility proofs by Abel, Lindemann, Galois, others. And Hilbert says this: when he elaborates on the point of his fundamental principle, he doesn't embrace the ideal of topical purity. He instead declares that his interests diverge from it. He says the foundation of this condition, purity of topic, I want arithmetical proofs of arithmetical results, geometrical proofs of geometrical results, etc., is nothing else than a subjective conception of the fundamental principle given above, my fundamental principle. In fact, the preceding geometrical study attempts in general to explain what are the axioms, hypotheses, or means necessary to the demonstration of truth of elementary geometry. And it only remains now for us to judge from the point of view in which we place ourselves as to what are the methods of demonstration we should prefer. So, find a criterion of simplicity. It sounds as if I'm throwing cold water on the project. No absolute notions of simplicity. These essences are not there prior to our work, but as we do mathematics, new things become simple for us that weren't simple before. On the contrary, I want to say, yes, find criteria of simplicity, continue to do so. And rather than ever think that ontological or phenomenological investigations have settled this matter once and for all, return to the task often. As Danto said, in order to awaken today's aesthete, one must apply shock treatment to him a la Duchamp or Warhol, who, by exhibiting the ordinary object as it is, managed to prod us in some way toward the creative. Similarly, in mathematics, by discovering that what is simple for us and that our distinctions between the complex and the simple change over time as mathematics evolves, rather than pursue absolute notions of simplicity, we will be more awake to the changing landscape of mathematical thought, which hopefully could inspire new creative endeavors. Thank you again.